All right, so 5.2 is um, looking at quadratic equations in factored form and vertex form and being able to pull out the things or the key features of each. So in 5.1, we did a lot of this. The part that's going to be a little bit different for factored form is that we also can find x-intercepts. And so as we look, we have our general form of a factored quadratic, which looks like this. The direction of opening is still the same idea of what's that value, that a value out in front. So if the a value is positive, then my u is gonna go up. If the a value is negative, then it's gonna go down. All right, so down, up. Oh, and again, we're looking at the a value that's out here in front. The other thing that we can tell from this equation is our x-intercepts. And what we do is we take each of these, and you guys did this in 4.5, where we take the factors of your quadratic and we set them equal to 0. So we go x minus p equals 0, and we solve by adding p to both sides. So we get x is equal to p. And so that's why we have one x-intercept at p, comma 0. And then we have our other x-intercept by taking the other factor, which is x minus q. And normally those are numbers. And we're going to add q to both sides. And so we get our other factor as x is equal to q, or q sub 0. And so we did this whole idea of solving for your value in 4.5. And that's all we're doing. So we're just adding to that. Now our y-intercept, just like before, if we had it in standard form, it was that c value at the end. But now that we have it in factored form, we have to actually solve. And the way we're going to do that is we're going to take the value, we're going to have x be 0, and we're going to plug it into our equation and solve for y, or the f of x. Remember, f of x is the same thing as y. And so we just take the 0 value, we plug it in everywhere there's an x, we do the math, and we get a y value, and that's the y-intercept. Our vertex then is our hk. So remember, the way we found it before was we did the negative b over 2a. When it's in factored form, we can't do that. And so what we're going to do instead is we're going to find the halfway mark between p and q. So we're going to have a value of p, we're going to have a value of q, and what we want to do is figure out what the halfway mark is. Okay, so these are my two values. We want to know what's the middle piece. So what's the halfway mark? So as you're looking at that, whatever that happens to be, so like if we pretend, let's say this is -4, and let's say this is 6, the spaces between -4 and 6, there's 10 spaces there. And so you're going to go 5 spaces, which would mean that the halfway mark is 1, because you're going to go -4, or 4 spaces to 0, and then 1 more, so that you've got 5 on this side and 5 on this side. So that so this value right here, this would be the x value or the h value of your vertex. And then we're going to take that value that we get, and we're going to plug it into your equation for the x values, and we're going to solve, and we're going to get the k value. Then domain, same idea. Domain is always -infinity to infinity, and the range are your y values. So it's the y value of your vertex, and then it's either up or down based off of that. So finding domain and range will be exactly the same as what you did before, because as soon as you know your vertex value, then you know what your range value is. All right, so that's that k value here. All right, so it's going to be, if it opens up, you're going to have your range be from the vertex point k to infinity. If you're remembering that if it goes up, this is your k value. So k to infinity. If your parabola is going down, then here's your k value of your vertex, and it's going from that point, from -infinity up to that point. So just kind of be careful. So as we look at example 1, it's done for you, but we just want to point out the pieces that you can tell from there. So notice that you've got f of x is equal to x minus 1 and x plus 3. That's the same. So we're just saying, okay, if we were to put this in the form x minus p, here's your a value, This is x minus q. That's the general form, right? So they're just saying, notice that if it's x minus 1, x plus 3, there really is a 1 out in front. The minus p, we're good. It's minus a negative 3. So the minusing a negative is how we're getting that plus 3. So if I wanted to write it exactly in the general form of a factored quadratic, that's that minus a negative 3. So we're just trying to be careful there. All right, when we look at the a value, you're noticing that it's a positive 1. And so because it's a positive 1, it opens up. The x-intercepts, again, we take those values. So we're going to go x minus 1 is equal to 0. And we take the other factor of x plus 3 equals 0, and we're going to solve. So we add 1 to both sides to get x equals 1. So there's my first x-intercept. We subtract 3, and we get x equals negative 3. And there's my second x-intercept. All right. To find the y-intercept, remember we take x equals 0. So we're going to take x equals 0, and we're plugging it in everywhere there was an x. So if you go back to your original equation, there's an x here, and we're going to put in a 0. So we're going to go 0 minus 1. Okay, there's an x here, 0 plus 3. 0 minus 1 is negative 1. 0 plus 3 is 3. And when we multiply negative 1 times 3, we get negative 3. So that makes it so our y-intercept is at 0, negative 3. And then to find our vertex, we're doing the midpoint. So again, notice that we've got our points from negative 3. This is just another way to look at it. Negative 3 to 1. So the distance between that is 4, right? So there's 4 spaces here. And so 4 divided by, oh, no, there's not. Yeah, there is. So 4 divided by 2 is really 2 spaces. So that's kind of where we're going. So there's 2 spaces here and 2 spaces here. So if I go 2 spaces from negative 3, then I'm at negative 1. All right. So we just want to be careful there. If we look at if the distance, if we add those two values together, 1 plus negative 3 is negative 2. Negative 2 divided by 2 is negative 1. So anyway, distance. So that's one way to look at it. When you get x equals negative 1, then we're going to take negative 1, and everywhere there's an x, we're going to plug in negative 1. So remember our equation again. Up here, we've got the x minus 1, x plus 3. So instead of putting in x, we're putting in the negative 1 that we found. So we're going to go negative 1 minus 1, which is negative 2. Negative 1 plus 3, which is positive 2, and negative 2 times 2 is negative 4. So your vertex then is the negative 1 point from here that we found, the halfway mark between the two, and then our value that we got once we plugged it in. So here's my vertex. And then your max and min point, that's just your vertex point. So in this case, we're going to have negative 1, negative 4. And then our max min value, the value, notice when it talks about a point, we're talking about the vertex point, okay? So here we are at negative 1, negative 4. When we talk about a min or max value, we're usually talking about the y value. So the minimum y value, or the smallest y point that we get to, is the negative 4. Our axis of symmetry, just like you did in the last section, it's that value that comes through the vertex. So in this case, it's x equals negative 1. And then our domain are all numbers. And then your range is going to go from that vertex point up to infinity. And so because it's included, it's got a bracket. All right, so we're going to stop there. And then the next video, we're going to go through 2 examples from the beginning.